Welcome to a walkthrough for enabling Layer 3 high availability in the Juno release. A couple of files we have to take a look at and make sure that they're enabled properly for L3HA. So the first one is the neutron comp file. So in the Juno release, you cannot have the distributed virtual router or DVR enabled at the same time as the L3HA functionality. So we can see here that we've got the entry for false for DVR, true for L3HA, and then I'm taking the defaults for everything else on the max routers, bin routers, and the default L3HA network 169.254, and we'll see more about that in the configuration. The next place is on each of the nodes that have the L3 agent, and you need a minimum of 2 nodes that are running an L3 agent on each one of them to get the high availability pair to work. In my case, I'm running network nodes. Then you need to go in and touch the L3 agent INI file. Again, in here, I'm basically taking the defaults. I'm using a password. I've set the password, and I'm using the default interval for the VRRP advertisement. From a high level, from a kind of a topology view from within inside the tenant space, what we have here in this example is an internal network 10.10.30 that is communicating to the pair of routers or L3 agents via these bridges. So not to get into OVS or Linux Bridge or anything else, that doesn't really matter here. What we want to look at is from a high level how these routers communicate. So VRRP is using this 169.254 network, and I'm showing a direct link here, but as we'll see here in a few seconds, that's actually traversing these bridges via a dedicated HA network. So pretty much like all first hop redundancy protocols, you go through some sort of election routine, and very often it's based upon the priority value that's set, and one of these two are going to be the VRRP master. In this case, on the left-hand side, we've got this master, which is now answering for the default gateway information, and then we've got the backup router. So let's take a look at this from a host view, and then let's break into the console and take a look at this in a much more in-depth way. So from a host view, we've got a compute node and 2 network nodes. In this example, we've got a tenant router on each of these network nodes, or the L3 agent on each of these network nodes, and we have a process running of keep alive D. So what you see new that you don't normally see in a non-HA environment is that your bridge is communicating not only over its standard QR prefixed port, but it also has this new port called an HA prefix port, and that is for keep alive. And basically what is happening here is that we have that dedicated HA network that is traversing these bridges and communicating back and forth. And what that's doing for us is that's allowing this VRRP v2 communication to take place over that network, so that we have tracking interfaces. We've got master and backup election and so forth. So from a high-level traffic flow, if we have a virtual machine that's running on a compute node, and it's either going out through a VLAN interface or through a tunnel end cap, in this example we're running VXLAN, so the virtual machine is simply following the path to its default gateway, which this master is holding the role for. So the traffic would traverse the tunnel interface, back out on the network, decap off its tunnel interface, and then pass up on into the L3 agent, and then we would go based upon the destination. We would either get routed to another tenant or to another node on another host, or maybe even through this QG prefix that takes us on out to the internet and so forth. So that's kind of the traffic flow for how this works. Now let's kind of look at the console and kind of follow this path of what's being configured on each of these nodes. So we've got a console to each of our nodes, and we've got if I get to it, we've got an interface open to our dashboard. So from a tenant perspective, this is all they see, that they've got an instance, they've got a network, and they've got a router. They don't know that there's multiple agents involved. They have no idea how many network nodes are involved. They just see their network, their instances, and their routers, okay? So in this case, it's a pretty straightforward environment. Now, if we look at the router's configuration, and again, we're logged in as admin, we're going to take a look at the private interface here, the public interface, and then these two HA ports that are created out of that 169.254 space. Okay, so a couple of things about this. One, you as a non-admin user, you cannot enable or disable HA on your routers. That is an admin level role. So again, there's no interface, if you will, if we wanted to go in here and create a new router in this particular environment. There's nothing that is going to tell us it's an HA or non-HA mode. Now, if we break out here into a configuration perspective, we can do a router create. And we can set the HA flag to either be true, which we don't need to do because HA is enabled by default. But if for some reason we wanted for a tenant to go and create a non-HA router, I'm not sure why we would do this, but if we wanted to do that, then we could set that flag to be false and then name our router and off we go, okay? But again, that HA flag is only available to an admin user. So a couple of other things that we want to look at is that we want to go and find out which of these two nodes, this control node happens to be my controller and a network node, and then I have a dedicated network node as well, okay? So what we want to do is we want to go and take a look at the HA comps path in the state environment for Keep Alive D and find out if we're master or if we are in a backup, okay? And then, if you recall, one of the configurations that we had in our agent config was basically this path, okay? And so there will be this namespace that was created when the router was built, so that's pretty easy to find. And then we just list the states, okay? So we're the master, and then if we break over here to this one, I've already run this command, we can see that the state on this other network node is in backup state, okay? So now we know who's master and we know who is the backup. So now the next thing we want to do is we want to take a look at our namespace stuff here. And we want to get into that namespace that our router is running on. And we want to take a look at a little bit of interface information because we're going to use that HA interface that is built on each of these nodes and go basically run a TCP dump so that we can watch VRRP functioning here, okay? So with inside of that namespace, we'll see that we've got, our loopback. We've got this new wacky looking HA prefix that we talked about before, and we can see that we've got these addresses, the VIP address and the real address for that network. There's our external gateway out to the public network, and then there's our router interface going there. So that's pretty standard. But what is new here is this HA prefix, okay? And so we're going to take a look at this this interface, and we're going to run a little TCP dump against that. So we're going to come back up here. And we're going to watch this VRRP information go by, okay? And so we can see here, we'll go ahead and stop that there. We can see that our address is advertising out to the well-known 224.0.0.18 VRRP v2 address, and we're just sending that advertise out there, and we're running an auth type simple, and we're doing it on the priority and the intervals and so forth. So we can see that that's going on, and if we went to the other node, we'd be able to see it advertising as well. So now what we want to do is we want to kind of take a look at, well, where does this come from? Where does the actual Keep Alive information come from? Okay, and so we can go back up to where we looked at that state, and we can actually go in and take a look at the keepalive.com file, and we can see all kinds of stuff in here. So this is the default template file. that comes with Juno. And so we can see here's some stuff around the sync group. We can see that we've created an instance. There's the address. There's the priority. There's that advertise to. Those are the things that are basically generated out of the configuration files that we looked at before. We can see that we're tracking that HA interface. We're actually going to fail that interface here in a little bit to take a look at the actual failure mechanism that VRRP has. Here's the VIP information that we looked at before, and then we've excluded these addresses. In this case, we've got the private gateway address, we've got an external router address, and then this happens to be a floating IP address that came with my heat deployment on this particular build. And then we've got a default gateway that actually goes out to the external public network that takes me to the internet. Okay, so that's kind of how all of that stuff is generated from there. So now what we want to do is we want to go over here and we want to take a look at this particular node. So we're gonna go and connect into that. Actually, you know what? Let's not do it that way. Let's do it through this interface because we will be able to see our pings go by as we fail these nodes. So we'll look at it this way. Okay, so we've got an instance here in that 10.10.30 network. We're going to just ping Google as everyone does to test their HA, and we're going to let that particular node run. And I know why that's not running because I happen to be off the network here. Give that a second to connect. There we go. And so that's basically the ping. We're just going to continue running there. Okay. So a couple of things that we can do here. Kind of shrink this up here so that we can see that a little bit better. Now that we know who is in active state and who is in backup state, we're going to go and actually fail our active state on this config. Okay. So one of the ways that we can do that is we can come in here, and now that we know this interface, we're actually just going to go and fail that interface on this active node. Okay. So what we're going to do is if you recall, we've got a track going on here for this particular interface. Okay, so we're going to shut that interface down, which the track will then fail, and VRRP will then go back into saying, okay, I'm in fault, and now someone else has to take over, which is the backup node. Okay, and so we're going to go ahead and down that, and we'll see that we'll have a little pause here as the state changes from this node from master, and it'll actually be in fault, and you can see it's already picked back up. So if we actually go back over here to our state command, we can see that we're in fault because that interface that was in there is in that was in the track list. Okay, so now we can see from this state that we're now the master node. Okay, so that's all I wanted to demo is kind of the functionality between the master and the backup, how the traffic is flowing. On your own you can run your OVS VSCTL show stuff, and you can take a look at how the bridges are all mapped, and what you'll find out is that it's pretty much like you expect it to be, with the exception of this new HA network. Okay, so go break it, go test some more, and thanks for listening.